In the middle of the night, high above the dark Atlantic Ocean, an Airbus A330 was crossing the empty sky toward Europe. Inside the cabin were more than 300 people. Some were asleep, some were watching movies, and almost no one had any reason to feel afraid. But at 39,000 feet, far from land, this flight was about to face a question no passenger ever once answered. What happens when a massive airliner loses the power of not one, but both engines? Below them was nothing but ocean. Ahead of them was one distant runway, and between the two stood only altitude, speed, and the skill of two pilots. Could a passenger aircraft with no working engines really glide all the way to safety? This is the story of Air Transat Flight 236. To understand how a modern jet came this close to disaster, we have to go back to the beginning of the flight. On August 23, 2001, Air Transat Flight 236 was preparing to leave Toronto Pearson International Airport for Lisbon, Portugal. The aircraft was an Airbus A330, a wide-body jet built for long ocean crossings, and nothing about the departure seemed unusual. On board were 293 passengers and 13 crew members. In the cockpit, Captain Robert Pichet and First Officer Dirk de Jager were experienced pilots, familiar with long overnight flights across the Atlantic. After takeoff, the aircraft climbed into the night sky and settled into its planned route. The cabin lights were lowered. Dinner service ended. Passengers leaned back under blankets, expecting to wake up near Europe. For everyone on board, this looked like just another routine transatlantic flight. But somewhere inside the aircraft, a problem had already begun, so small that no alarm could clearly explain it yet. While the aircraft continued east across the Atlantic, everything still looked normal from the outside. The Airbus held its altitude, the autopilot kept it steady, the engines sounded smooth, and inside the cabin the flight felt calm enough for most people to sleep. But near the number 2 engine, on the right side of the aircraft, a hidden problem was slowly getting worse. A fuel line in that area was being damaged by vibration and contact with another part. It was not a dramatic failure. There was no explosion, no fireball, and no obvious sign that anyone in the cockpit could see. Instead, fuel began escaping quietly, drop by drop, then faster. At cruising altitude, in the darkness over the ocean, that kind of leak was almost impossible to notice with the human eye. To the pilots, the airplane still appeared to be flying normally. To the passengers, nothing had changed. But inside the system, the flight had already started losing the one resource it could not survive without. And the first clue would not look like a fuel problem at all. Then the first visible clue appeared, but it did not look like a fuel leak. In the cockpit, Captain Robert Pichet and First Officer Dirk de Jager noticed unusual engine readings. The number 2 engine was showing low oil temperature and high oil pressure, a combination that did not fit the pattern pilots normally expect. If oil gets hotter, pressure often drops. But this was different. The numbers seemed to be moving against normal logic, and that made the warning harder to understand. The aircraft was still flying smoothly. There was no smoke outside, no sudden shake, and no clear sign of damage. So the crew began searching for an explanation inside the manuals, trying to match the warning with a known failure. They also contacted Air Transat Maintenance Control in Montreal, but even from the ground, the answer was not obvious. At that moment, the most reasonable explanation seemed to be a faulty sensor, a strange reading, not a dying fuel supply. But while everyone focused on the oil warning, the real problem was still hidden, and the fuel was still disappearing into the night. The next warning was harder to dismiss. The aircraft's fuel system began showing an imbalance. The right side had less fuel than the left, even though both engines were supposed to be using fuel at a predictable rate. For the pilots, this created a difficult problem. A fuel imbalance can affect the aircraft's balance, and there are procedures for correcting it. From the information they had, the safest move appeared to be transferring fuel from the fuller tank to the lower side. So the crew opened the crossfeed system, expecting the fuel levels to even out. But there was one thing they did not know. The right side was not simply low, it was leaking. That meant fuel from the healthy side of the aircraft was now being sent toward the damaged system, where it could escape through the hidden break near the number 2 engine. The pilots were not careless. They were working with confusing warnings, limited information, and a situation that did not clearly reveal itself. To them, this looked like a balance problem. But in reality, the correction was feeding the leak. Minute by minute, the numbers on the fuel display kept falling. What had started as a strange technical issue was now becoming a race against distance, darkness, and the empty Atlantic below. As the fuel numbers continued to drop, the cockpit changed from confusion to calculation. Captain Robert Pichet and First Officer Dirk de Jager now had to think beyond the warning messages. The aircraft was still flying, but the fuel was disappearing too quickly for a normal flight. Somewhere, somehow, the airplane was losing more than it should. They needed a runway, and they needed it fast. Ahead of them was Europe, still too far away. Behind them was Canada, no longer an option. Around them was the Atlantic Ocean, with almost no place to land a wide-body aircraft. The closest realistic choice was Lajes Air Base, on Terceira Island in the Azores. It was a military airfield in the middle of the ocean, and at that moment, it became the only hope for everyone on board. The pilots turned the Airbus toward Lajes and began working the numbers. Distance, altitude, fuel remaining, engine performance, every second mattered now. In the cabin, most passengers still did not know how serious the situation had become. To them, the flight was quiet, maybe slightly unusual, but not yet terrifying. But in the cockpit, the truth was becoming harder to ignore. This was no longer just a strange technical problem. It was a race between how fast the aircraft could reach land and how fast its fuel would disappear. Then, the race became real. The right engine, the same engine connected to the damaged fuel system, began to lose power. It was not a fire. It was not an explosion. It was something quieter, and in some ways, even more frightening. The engine was being starved. Without enough fuel reaching it, the number 2 engine could no longer keep running. One of the 2 massive engines that had carried the aircraft across the Atlantic slowly fell silent. Inside the cockpit, the situation changed instantly. Captain Robert Pichet declared an emergency and informed air traffic control that they had lost an engine. An Airbus A330 can fly on one engine, but this was different. The aircraft was still losing fuel, and the crew could not be certain how much longer the remaining engine would keep running. Now every mile toward Lajes mattered more than before. The airplane was still in the sky, but its safety margin was shrinking fast, and the most dangerous question was still unanswered. Was the remaining fuel enough to reach the island, or was the second engine already living on borrowed time? Minutes later, the warning the pilots feared became unavoidable. The left engine began to lose power too. It had been the aircraft's last source of thrust, the one thing still pulling the Airbus through the night. But with the fuel supply nearly gone, even that engine could not keep running. Then it stopped. For the first time, Air Transat Flight 236 was no longer a powered aircraft. Both engines were silent, and the giant jet was now moving only because of its altitude, its speed, and the shape of its wings. Inside the cabin, the change was impossible to miss. The steady roar that passengers had heard for hours faded away. The lights dimmed. Systems that depended on engine power began shutting down, and the aircraft slipped into a darker, quieter kind of emergency. But the airplane was not completely dead. A small device called the ram air turbine deployed into the airflow beneath the aircraft. As the wind rushed past it, the turbine began to spin, producing just enough emergency power for the most important instruments and flight controls. It was not enough to bring the engines back. It was not enough to make the aircraft normal again, but it gave the pilots one final chance. High above the Atlantic, with no engine thrust left, a wide-body passenger jet had become a giant glider. And somewhere ahead in the darkness, Lajes Air Base was still waiting. In the cabin, the emergency was no longer just something happening behind a locked cockpit door. Passengers could feel that something had changed. The deep engine sound that normally filled the aircraft was gone, replaced by the sound of air rushing around the fuselage. Some people looked up from their seats. Others turned toward the windows, seeing only darkness outside. The cabin crew now had one job: keep everyone calm and prepare them for the worst possible outcome. They moved through the aisle with controlled voices, giving instructions as clearly as they could. Passengers were told to put on life jackets and prepare for a possible emergency landing. For many people, that meant one terrifying thought: the airplane might not make it to land. But the cabin did not become chaos. There was fear, confusion, and silence. But the crew kept the situation from turning into panic. Families stayed close. Passengers listened carefully. Every small instruction suddenly felt important. Up front, the pilots were still fighting for the runway. Behind them, more than 300 people waited in the dark, not knowing whether the next place they touched would be concrete or the cold Atlantic Ocean. With both engines silent, the pilots were no longer flying the Airbus in the normal sense. They were managing energy. Every foot of altitude was now like money in a bank account. Spend it too quickly, and the aircraft would end up in the Atlantic before reaching land. Save too much of it, and they might arrive over the runway too high and too fast to land safely. A large passenger jet does not fall straight down when the engines stop. Its wings can still create lift, as long as the pilots keep the right speed. For every amount of altitude the aircraft loses, it can travel a much longer distance forward. That glide was now their only path to survival. Captain Robert Pichet focused on keeping the aircraft stable, while First Officer Dirk de Jager worked the distance to Lajes Air Base. The calculations were not just numbers anymore. They were the difference between a runway and open water. Too slow, and the aircraft could lose lift. Too fast, and they would waste precious altitude. Every adjustment had to be careful. Outside the windows, the Atlantic remained dark and empty. Somewhere ahead, a small island held the only runway close enough to matter. The pilots had one goal now: keep the giant glider alive long enough to reach Lajes. And as the island came closer, a new problem began to appear. They might actually make it to the runway, but they were arriving with far too much speed and altitude. As Lajes Air Base finally came into view, the cockpit faced a new kind of danger. They had made it across the ocean without engine power, but now the aircraft was too high, too fast, and too close to the runway. In a normal landing, pilots can use engine power to adjust their path, slow down, or climb away and try again. Flight 236 had none of those options. There was no go-around, no second attempt. If they missed the runway, the aircraft would continue toward the edge of the island, where rocks and ocean waited beyond the concrete. Captain Robert Pichet had to lose energy fast without losing control. He began turning the aircraft in wide, controlled movements, using the air itself as resistance. Each maneuver burned off altitude and speed, but every turn also carried risk. Bank too sharply, and the aircraft could become unstable. Stay too shallow, and they would arrive too fast to stop. The runway was now ahead of them, but the Airbus was still moving faster than it should. The landing gear came down, adding drag, and the aircraft settled lower over the island. Inside the cabin, passengers braced for impact. In the cockpit, there was no room left for hesitation. After crossing the Atlantic as a powerless glider, Flight 236 had reached its only chance at survival. Now the entire story would come down to the final seconds above the runway. The Airbus crossed the threshold at high speed. Captain Robert Pichet held the aircraft steady, trying to keep the nose aligned with the runway as the ground rushed up beneath them. There was no engine power to correct a mistake, and no runway left to waste. Then the main landing gear hit the concrete. The touchdown was hard. The aircraft bounced, settled again, and began racing down the runway with far more speed than a normal landing. The tires took the force first. Several of them burst under the pressure, and sparks flashed from the landing gear as the pilots pushed the brakes as hard as they could. Inside the cabin, passengers felt the violent impact and the long, grinding stop that followed. No one knew if the aircraft would stop in time. Meter by meter, the Airbus slowed. Finally, after rolling down a long stretch of runway, Flight 236 came to a stop at Lajes Air Base. For a moment, there was only silence. Then, the reality began to sink in. Nearly 300 people had crossed part of the Atlantic with no engine power, landed at high speed, and survived. After the aircraft stopped, the survival story became an investigation. The question was no longer whether the crew could save the airplane. They already had. Now investigators needed to understand how a modern Airbus A330 had lost so much fuel over the Atlantic without anyone seeing the leak clearly in time. They focused on the right engine area, the same side where the first strange warnings had appeared. When the engine cowling was opened, the clues began to make sense. There were signs of fuel leakage, and one fuel pipe showed damage from rubbing against another component. This was not a mysterious failure in the sky. The disaster had started earlier, on the ground. Before the flight, maintenance work had been done on the aircraft, including work connected to the right engine. During that process, parts from slightly different configurations were used together. They looked close enough to fit, but in aviation, a few millimeters can be the difference between safe clearance and dangerous contact. Once the engine was running, vibration did the rest. A hydraulic line and a fuel line were too close. During the flight, they rubbed against each other again and again until the fuel line was damaged. Then, fuel began escaping from the system, hidden inside the engine area, far beyond what the pilots could see from the cockpit. That tiny contact point explained the strange oil readings, the fuel imbalance, the engine failures, and the terrifying glide toward Lajes. Flight 236 had not been brought down by one dramatic explosion. It had been pushed toward disaster by a small maintenance error, repeated vibration, and a leak that stayed hidden until almost everything depended on it. In aviation, small mistakes do not always stay small. Air Transat Flight 236 showed how one maintenance detail, almost invisible at first, could place nearly 300 lives in danger over the middle of the Atlantic Ocean. A damaged fuel line, a confusing set of warnings, and a hidden leak turned a routine overnight flight into a test of judgment, training, and survival. But it also showed something else. Technology mattered, procedures mattered, emergency systems mattered. But in the final moments, it was the calm decision-making of Captain Robert Pichet and First Officer Dirk de Jager that helped bring the aircraft to the runway. So what do you think was the biggest failure in this story? Was it the maintenance work, the system that failed to make the leak obvious, or the cockpit decision to transfer fuel? Share your thoughts in the comments. And if you want more real survival stories like this, like the video, subscribe to the channel and turn on notifications.